Hi, I'm Bob Brincheck. I'm from a company called PTC. I'll give you a little bit of background on myself. I'm actually a mechanical engineer. I've grown up in the area, started out working in the automotive industry. Was an engineer at General Motors for a few years and then ran product development for a supplier for in the mid-90s. And then actually I made the transition from being an engineer into the technology space. So actually I worked actually for PTC my first time around in the late 90s. Ran different aspects of what they call global services, helping customers deploy the solutions and gain value out of them. Then I worked for a competitor for a number of years, and now I've been back for PTC for the last 9. So one time I used to like to say I was more of an engineer than a technologist, but those days are behind me. So what that allows me to do really is help companies understand. I have a lot of experience basically working with companies to understand how they execute transformations, because we're also at PTC, we work on the product development side and everything around products. So the tools to actually design them and develop them, manage all that information through the life cycle, push that down to the manufacturing floor, monitor what's going on in the manufacturing floor, and even monitor what's going on in service. So when we work at, we talk about transforming, we're talking about basically transforming and touching, in many cases, everything in the company, or most everything inside the company. And it's a pretty challenging area. So again, PTC, just real quickly, we're a $1 billion company. We're actually out of Boston. Recently moved into our new headquarters there down at Seaport. So we're in the tech hub center of Boston. Company's been around for about 30 years, if you're not aware of it. We're also in the industrial Internet of Things space. We're one of the dominant players actually in that space. We're about the only company to show up in all of the various Magic Quadrants or vendor assessments by the major industry analysts, as well as we've won a variety of awards from the industry and our partners. So the exciting thing about the only reason I bring this up is this really gives us the opportunity to actually work with a lot of very cutting edge companies, because this is still a space that people are really kind of curious about. How do I work with this, right? What do we do with this? This is not obvious. And on top of that, it being the technology behind it, people are also used to saying, okay, well, what do? I go buy an enterprise system, I go figure out exactly how I want to use it, and then I put it in production and I keep it that way for a fairly long period of time. Think of an ERP system or product lifecycle management system like we do. That's not the approach that works with this, because the other thing is, okay, I need this big enterprise system. What's my business case for this? What exactly am I going to get back? What's my total return going to be? Well, that can be challenging in some cases with this too, because that comes down to what are you inefficient at today, and what don't you know you're doing today that's incorrect that you could actually fix and be better at tomorrow. That's a difficult answer to. If you know the things, especially in the manufacturing space, that you're not doing, that you're doing inefficiently today, odds are you've worked at fixing it. There may be some problems that you understand you just can't fix. But in most cases, companies really believe, that goes back to even Deming, that they're as productive as they are able to be, right? So the only ways they figure out their things are different is when a disruptor comes in and enters their territory. So that's a lead in really to this. So the good thing though is that most companies, 91+%, actually understand that they need to transform the way they're doing manufacturing, and they need to invest in digital factories, or at least the term digital factories. They're, over 2,000, they're actually implementing these as well, and a ton of technology spending, actually upwards of 40% of that is actually getting spent on that. So people understand the need to transform. And again, when we're talking about transforming, we're not talking about incrementally improving what we're doing today. That's the interesting thing about this space right now. We're really talking about helping people move to the next way of doing work, right? So if I'm an operator and I'm running a machine, if the machine becomes smarter and is more automated, I'm not necessarily running the machine. What I am doing is I'm monitoring what's going on that machine or maybe other machines, and understanding where I'm needed at a particular period of time. I'm no longer just going down and every half hour I'm writing down something or entering some certain values into a screen or writing them down on a piece of paper. That's not value added. So we have to understand now how to better utilize people, how to better run process material through the plant, really how to do what we're normally doing in a completely different way. So good news, though, is the objectives really haven't changed. We're still trying to achieve the same types of things: reduce operational cost, increase revenue growth with the assets we have, and increase asset efficiency. So become better at what we're doing. And in many cases, especially like the automotive industry, where this is very helpful and is actually being heavily investigated, and there are many of the early adopters are in the automotive space, is because they've been doing this type of continuous improvement for 30 plus years, and it's also an extremely competitive space. And in many cases, you've kind of run out of what you can do, right? You understand you're as efficient as you possibly can be. There's maybe the option of going out and buying some massive, new piece of capital equipment, but does that really pay for itself? So what this allows you to do is take a look at, it's no longer the cell or the space or even the potential line, but how is my overall plant doing? How are my other plants around the world doing that are actually making the same product? Does somebody have a better idea? Is somebody doing something better in some other plant building the same product that I can actually share with those other locations? So it's really kind of expanding now beyond either the line or the plant floor and taking these, achieving these objectives over the entire corporation. And again, what's really changing is the approach, right? So like I described, in the 80s and into 90s and even today in various industries, there's a continuous adoption of lean, right? The Six Sigma principles, lean principles on removing waste from the manufacturing environment. In the 90s, there was a push to reduce costs by offshoring and outsourcing. That was enabled by the fact that now you have the internet, now we can actually communicate. So if I do have work in another location, I'm not my only way of communicating with them live is no longer the phone. I can send them data, I can actually receive data back, I can build a level of trust with that remote location that actually we're doing what we need to do and it's not going to cause a problem. In the 2000s, we're able to do things more like, when they talk about next shoring and automation, we're able to now actually bifurcate the process even further. So now maybe I have certain plants that provide globally other plants, pieces and parts for other plants because they're more efficient and effective of it. I can actually decrease my supply chain. And you can see this, again, kind of come out of the automotive industry. In the 90s, there was a big push to actually outsource large portions of the vehicle. The entire interior of the vehicle will go to JCI or Lear or Magna or companies like that. Those companies bought up a lot of companies that did that. Then what happened is in the 2000s, especially the late 2000s, now what happened is the technology of organizing and managing the logistics of bringing all these different products together had matured to the point that the OEMs didn't want that anymore. Now they wanted to source all those independent pieces separately because it's more cost effective that way. So in many cases, those companies ended up diversifying different divisions. So now we're to Industry 4.0. And really what we're doing here is the technologies have improved again to the point we can actually gather a much richer set of data out of everything that's going on in the plant and also tie that back to what's going on in development. And the way we like to look at this is what we call the physical and digital world, and our company has actually adopted the yin and yang approach. We've actually made our logo this way. If you look at it, our logo is a P on the top and a D on the bottom to represent the physical and digital. And the idea is now in the digital, we actually have all the products are digitized, they're designed in things like CAD tools, the plants are actually, the processes are simulated, we're keeping track of everything we build and ship, and we understand the quality information is coming back digitally. So we have a rich set of digital information on what I was supposed to build, when I built it, how well I built it, how exactly I built it, etc. We also have, on the physical side, the things that are actually doing all that work. Now with IoT, we can actually, and augmented reality, we can actually bring those things together. So we can actually pull data directly from the physical things into the digital things in real time. So I can now go to a machine and I can see not only what it's running, but what it should be running, and pull information from both sides of those systems, from IT and OT, information technology and operational technology, together in one place and compare. Am I actually making it correctly? What are the capabilities of my machine today? Maybe that actually allows me to produce a less complicated design. On the AR side, we can actually then take the way things are supposed to be, all that design information, lay them over top of the actual physical part, and show people, use that for training, use that for inspection, use that for identification. Okay, so the most interesting and highest value items really kind of come when these things meet, when I can bring that physical and digital world together, and that's often referred to as a digital twin. So again, what makes Industry 4.0 different is we're actually bringing a lot of this information all together now. So for a long time, we've had a variety of different sources of information, tons of places to gather data. One of the other things that's been driving it is sensor technologies actually become much less expensive, so we can incorporate those into more things, especially products, and use that to gather information as well. But the primary thing is we're gathering information, we're gathering data from wherever the sources happen to be, the products in test, the products in the field, the machines putting it together, et cetera. But data is just data, right? And this is where often the first place some companies go down is, I'm going to start gathering all kinds of information and all kinds of data. Then they get data and they go, what the heck is all this stuff doing? I have no idea what all this data is. And then they jump straight to something like machine learning and AI, and they say, well, let's just, let's run machine learning algorithms against it and figure out what we got. Well, if you're the speaker before me was the CIO for Quicken Loans. If you're applying that to figure out why people make a loan, that's a perfect application of machine learning, because that's a really good question. There's no physics necessarily behind why people are making certain decisions. But if you're trying to figure out why this part actually failed, there is a physics reason behind that. There was nothing random behind it. Something happened at some point in time. You should also, being the people that designed the product, have a pretty good idea of where that went wrong. So we don't need to start with all the data in the world and try and figure out where my problem comes from. What you need to do is be able to contextualize that data. So you need to be able to say, okay, I've got a part, I've got a problem. I think that problem happened in the manufacturing plant, and I think that problem happened in this part of the process. That's where it probably or should have happened. So I need to understand which slice of data do I have that comes from that part of the process. So when I'm gathering all this information, I'm gathering it in context. This is the place where I manufacture this part of the process for this specific part. And it's already organized when I'm gathering it, so I can go back at any time and quickly and easily find it. Once you've got it contextualized, and we're pulling data from a variety of different places as well, right? So it's not just directly from the machines, it's actually from the systems we have internally as well. Because for the example I described, I need to know, from my ERP system or my MES system, what I'm building at any one given time on this machine. From the machine, I need to, gather certain pieces of information, and even from the design system, I need to know whether this is important or not at all. Is this a critical characteristic? I'm a process that's tied to my PFMEA that I need to monitor, or is this just something that doesn't matter? Once I have all this data in context, then I can start to synthesize it. Then I can start to do very interesting things with it. I can now actually analyze it, right? Or I can analyze it more intelligently. I can take a look and gain new insights out of it. Am I actually, at the lowest level, is my equipment actually more or less capable than what my design thinks it is? That's an important area. You can save a lot of money. Being an engineer, and when I talk to manufacturing folks, I tend to endear them by admitting the fact that engineers can make anything Six Sigma tolerant. All I have to do is just add decimal places to it. That doesn't mean they can necessarily make it, but my math works. So it's critical to understand, are the processes that are actually making this design capable of achieving what I expect them to achieve? Or do I need to produce a design that's actually that meets the capabilities of my equipment? Alternatively, am I actually measuring something and think that something is important that I can make all the time, 24 hours a day, for months and years at a time, and never bother with it, because now I'm actually gathering and wasting a lot of time measuring something that will never go bad. So it's important to be able to run this information and learn that and understand that. And also, we're looking at more than just, when we talk about analysis and synthesizing that data, we're looking at more than just upper and lower boundary type conditions. So a good example is person's heartbeat, right? You have 2 upper beats and 2 lower beats. If you try and do upper and lower bounds, that won't work. If they're all upper beats, you have a problem, and you need immediate attention. So it's really, if you're running faster, your heartbeat's going to speed up. If you're running slower, if you're sleeping, your heartbeat's going to slow down. That's not a bad thing. That just means that's context-based, or that's based on where you're at in that particular cycle. So when you're looking at this information, we're looking at long-term trends and what is actually, what is the performance that I'm looking at over time, and what is actually affecting that? Am I actually trending out, or am I just moving to the high side of tolerance and I'm going to drift back down because of certain conditions? So I've synthesized that information. Now I can actually orchestrate it. What we mean by orchestrate is I can take action on it. So when I understand why something fails, or what a high probability predictor of something failing is, be it a machine that's under, we do a lot of work with predictive maintenance. So that is monitoring equipment to understand well in advance, 24 hours plus in advance, when it's going to fail or when it's going to go outside of tolerance, when it needs maintenance. Because that's huge, right? You don't want to find out about it when you're running production. You want to find out about it when you can fix it before it takes you down for hours or days. And in order to do that, we can now not only just predict and say, hey, somebody looks at a report and says, oh, this thing is probably going to do it. We can actually keep the algorithm running, monitor the machine, and when the algorithm detects that has learned the capabilities of the machine, when the algorithm detects that we're actually going to have a maintenance event in 24 hours, it can actually notify maintenance. It can put an order into the asset management system and say, hey, this thing needs to be fixed, right? And eliminate the different needs for that. A much simpler solution of this too, example is I worked with one customer. They make cabinetry, so they're in a plant that's sawing and cutting and sanding a lot of wood. There's a lot of dust in the air. So they have their programmable logic controllers in a cabinet, and that cabinet, there's air circulating through it. When the filters get clogged up, the cabinet heats up and the PC boards overheat. So in their case, they can just simply put a temperature sensor inside that cabinet, and when it reaches a certain temperature, maintenance gets a text that says, hey, you got to clean out the cabinet. And now they keep their machines running. So I can orchestrate that information, and then I can help people engage, which is also things like notifying maintenance they've got a job to do. Another key area of this too that I'll get into is work instructions and things like that, communicating information to the floor. So instead of giving you a description, a text description, if anybody's ever put toys together, built anything like that, and you get the instructions out, it tends to be an interesting challenge. How do I interpret this? Am I interpreting this correctly? What's much more interesting and much easier to do is if you can visually see how this stuff actually goes together. If I can take my tablet and I can put it up there and I can see the part, that's basically what we use a lot of augmented reality for, and see a lot of value in augmented reality too, is to take a simple device, doesn't even have to be wearables, and put it up there and see on the part itself, see my thumb come down and hit the button, right? So I know which button to hit. I mean, not that this is all that difficult, but you get the point. See what part needs to be replaced. See the exact proper way to take parts and put them in for that order, right? People are very visual, and to be able to see that very visually without having to interpret it is extremely helpful. So again, with that engagement, now we need to put it out to all types of different devices as well. So, and this is hugely important too, because we get, in the technology world, we get all gung-ho and excited about, all kinds of cool stuff. And the interesting thing is wearables seems like the very logical thing. Hell, I got glasses, put a little camera on there, I can see it. Maybe I can put a cool little VR thing on and I can, manipulate it in visually and see what's going on and everything else. But then I've got to, not to pick on any one particular vendor, but then I've got to interact with it, which is awkward, right? What we've actually found a lot of customers are much more easy to do is to take their device, their phone or their tablet, and point it at it and take a look at it and see it and leverage it that way. So you never really know what is, but that's today. So tomorrow somebody comes out with a really cool wearable that's really inexpensive and works very intuitively, and I'm sure it all shifts to that as well. So you need to make sure that whatever you're working with can actually output to any device that's actually needed at any point in time. So all these things really both need to come together and are coming together, which is unleashing a tremendous amount of power. And this is a critical best practice. If you were actually looking at implementing Industry 4.0 in your factory or working on these types of IoT solutions, you need to have all of these components. Because just because you can gather information is great, but you actually have to be able to do something with that information because people always want to, they know about this, they kind of have an idea about synthesizing, they certainly want to orchestrate, but the contextual piece is where we often miss out because you end up with too much data. So you really have to have a plan together on how I'm going to actually use all this information. Inside of a plant, or any organization, where the data lives today, it just makes it all that much more difficult. If you were starting up a company today, that's why it's always kind of, if you're starting up a company today, you can actually learn, take all these lessons learned, over decades and put stuff together that actually communicates and makes sense. If you've been around for just 10 years, let alone 50, 60 years, you've got data in a variety of different places and it lives there for good reason, right? And it's extremely expensive to try and rip it out and put it someplace else. And oh, by the way, while you're busy ripping it out, somebody needs to be actually making stuff. It's not like the company can shut down for 6 months, rework its infrastructure, and restart back up. That doesn't work. So what we need to do is we've got data at, if you've seen this ISA 95 model, you've got data basically at the machine level. That's the L1 level. It's sensing stuff. It's pulling data from sensors actually at the machine or in the robot or whatever it happens to be. You can have at the L2 level, there's data accumulators, things like SCADA that actually pull data off of the machine or a variety of machines and manage it at that level. Then you have production execution type systems like an MES that's at another level that's gathering that and tying it to what I'm making and taking a look now at more of a plant-wide level. And then you have the enterprise as well. There's systems across the entire enterprise that say this is what I'm making at this plant, this plant, this plant. These don't talk to each other. They've been made, you've made different decisions for different systems for very good reasons, good or bad. The idea of trying to rip and replace everything to solve these problems is not realistic. What really needs to happen, and where IoT comes in and industrial IoT comes in and provides significant value, is the ability to, what we prefer to refer to as wrap and extend. So we can actually pull that data. We can actually interface at the appropriate level. If there's some data down here at L1, we'll pull that piece of data. If we need to figure out, if we're monitoring on a machine what I'm making today, I need data from maybe the ERP or the MES system to know the thing I'm making and where I'm at, and then I need data from the particular machine or the SCADA to know the speeds and feeds and the information that was around that particular part, the process parameters for that particular part that were involved when it was made. So I need to pull bits of data from all those things, and I need to, again, create that contextual model. So I need something that can interface with all those as opposed to rip and replace. And that's really what the industrial and other things in these tools do and are providing value with. So a key way, too, I mentioned it at the beginning, most IT projects, especially for business enterprise, that involve enterprise-type engagements and systems, are large projects that you do a large amount of planning. They take 1, 2, 3 years, maybe more, to implement, and they're expensive, and you generally have a very large ROI going for it. That is the wrong model for this approach, because number one, the technology is actually much more Lego-like, if you will. So I can build something, I can build an application to pull data from a particular machine to understand the operating efficiency of that machine. I can then use that I can then do that for another machine and another machine and another machine. Then I can actually tie that information together to understand the operating efficiency for my plant. Okay, so what the key thing in this place is to actually start early. We say, like, wrap the information, pull data from different silos, start with a single business problem. Start with in the IT world, what's referred to as an agile approach, right? I start with a single problem. I know I'm going to take X amount of time, preferably 6 weeks, something like that, 6, 8, 10 weeks or less, to solve that problem. I'm going to make a complete sprint. I'm going to then try my thing out and make sure it works, and then understand the value I got out of that, right? And then build on that. If you're quality focused, it's really kind of plan, do, check, act. I'm going to do this one thing. I'm going to go and then I'm going to execute it, and then I'm going to take a look at what the data I've got out of it, and then I'm going to decide what I do next. Because when you're monitoring that piece of equipment, you may find some very interesting things. You assume it's working one way. It may actually be working something different. There may be data anomalies in there that may say, hey, now I want to actually take a look at this. Or if you are focused on trying to resolve a problem, and even you apply big data to this problem, you may find that none of your variables are statistically significant, at least to a true quality level. What that means is not that the machine's wrong or the data's wrong. What that means is not that the technology is wrong or the approach is wrong. Odds are you just aren't gathering the right data. You probably need more data. Maybe your process is environmentally sensitive. Maybe it's based on what's coming up upstream. So everything is useful, but you need to understand that this is like a Six Sigma type project as well. You come in, you define the problem, you do a short workshop on it, you address that issue, and you move forward. You plan, do, check, act. So it's the same approach here. We wrap the information, we start small, we then extend that, start tying things together, and then we can really start using it to transform the business. Because now when we start gathering more and more information, we can start making more significant decisions, and we can start actually doing more interesting things with it. So I also said I want to talk about companies that are doing this today, right? So around reducing operational costs, there's significant benefits to be gained to reduce operational costs. Brembo is an automotive company. If you're not familiar with them, they make brakes for high-performance products. They're the ones that if you ever see Porsches, Ferraris, and others that have a red brake caliper that you can see through the wheels, that's typically a Brembo brake. They really needed to, they were interested in reducing scrap and unplanned downtime. They have a lot of different products that they process, even though it's all brakes. Even though if I do front disc brakes and they're all basically the same kind of product, each one I give to each particular supplier is unique to that customer. So they have a lot of different products. They're running in smaller volumes, and they really needed to get a much better understanding of their business. So they were able to actually use this information, quickly put together some applications that allow the plant manager to see the operational efficiency of the plant, allowed the operator to see the information that they needed, and they're able to reduce scrap and unplanned downtime. Oops, sorry, wrong way. This is really kind of a cool one with Airbus. So, if you ever sat on the wing, over the wing on an airplane on the window, and you looked out, there's rivets everywhere, right? So planes are basically held together with rivets and mechanical fasteners. So, and they're all engineered, and they're they're as big as they need to be, right? Because if they're bigger than they need to be, then they add weight, and that is insanely expensive over, the lifetime of the plane. So there's a variety, when they come up to put rivets in and mechanical fasteners in, there's a variety of different holes, a variety of different things. So what they're able to do here, again, bringing the physical and the digital together, they actually built an application where they can come up with a tablet, take a look at that hole. It understands where it is on the wing, it understands the size of the hole, and it goes back and it checks from the engineering information, you need this fastener. And then it actually takes that information, pushes it down to the piece of equipment they're using to install the fastener. So it feeds the right fastener at the right torque with the right information, and records, by the way, all the information necessary to put that fastener in at that particular time, in that particular point, in that particular plane. So what probably took 3 or 4 different people, and probably took a lot longer because they had to look things up if they weren't already aware of it, let alone just recording the information, they were able to automate and dramatically speed up the production time while reducing errors and improving accuracy. Supporting revenue growth. There's a couple of different ways you can do revenue growth. I'm not going to get into it, but there's dramatic opportunities here for companies that really want to transform to actually completely change their business model, right? So if you think of it, now that I get information out of the field and I understand how my product is working, there's a lot of companies that actually have switched from just selling a product and letting it go out the door to turning that product into a subscription. Everything from medical equipment to mining equipment, right? If you wonder why they do that, just think of the cost justification for it. If I'm in finance and I'm at a mining company, it's infinitely easier for me to say that, if my subscription is tied to ore removal, then my understanding of my overhead is perfect. I no longer have to capitalize it and figure out exactly, go through a lot of complicated equations to figure out how much overhead I have to apply to, any particular operation. It's actually directly aligned with what I'm paying. And oh, by the way, if I'm not removing ore, I'm not spending money. And I don't have to worry about capitalizing a huge acquisition later on down the line. Another way really, and what we're going to talk about here to improve revenue growth is just increasing capacity in the plant, right? So instead of building a new plant, let's just make the current plant more efficient and effective and free up space to build more product. When we're doing that, we're working with a company. It's a really cool company, kind of a startup automotive company in Germany called Ego, and they're making fully electric vehicles, and they're actually doing that with suppliers. So the OEM is actually a very small company, and it leverages suppliers extensively to come in and both design and build systems in this vehicle. And what they create is really what we call a unified digital thread. So it's really understanding all the information to design, building that process information out of the design information, feeding that directly down to the plant, and then gathering information from the manufacturing process so that I can come back and see whether I've actually built the way I expect them to build. Right. So this digital thread, being able to, for a vehicle, come down and say, I built it with these parts, I built it this way, everything was done the way I needed it to be, and here's my record for that, is key. And it actually makes it much more efficient for them and allows them to execute this with far fewer people. Vestas is another interesting one. So they're more traditional manufacturer. They make they make obviously large turbine blades and that kind of equipment. And they were a more traditional company, right? They did things. Engineering did it, gave it to manufacturing, who did their stuff, and they eventually built them. And again, they're not running it. They're building turbine blades, right? So it's not like they're building 600 or 1,000 of them a day, right? That process suited them. But the problem in their case is actually the business took off far faster there, right? So everybody wants green energy, everybody wants windmills and turbines and things like this. So now the idea is, well, gee, in order to actually do this business, do I have to build a whole other plant and do all this other work? No, you can actually work at becoming more efficient. So they did the same type of thing that Ego did in a way of, number one, now actually they're doing all the design digitally, building their process plans and their instructions off of that and feeding that directly down to the workers. And the other advantage of that is because their products can also be customer specific. Now I directly, when that worker comes up, scans a traveler, they pull up the work instructions for that specific part, right? For that specific customer, that specific variant. They don't have to worry about having that information delivered to them in advance. So if there are any variations off of that, they get that directly, and they don't necessarily make mistakes or fall victim to errors on that. And they were able to significantly increase their output and handle that additional business. There's also asset efficiency, right? So easy way to think about this one is in plants, people meet in the morning, right? With the plant manager will come in with all the leads, and they'll take a look at what they did yesterday, right? And what are we going to do today? Well, if you built scrap for 3 hours on this cell yesterday, that's pretty annoying to find out the next day. Because now you either have to make that up, or if nothing else, you didn't meet your numbers, you didn't do what you needed to do. So it's far better to actually get notified about that instantly, or to be able to look and understand at where you're at any given time. And a good example of this is Hirotech, which is a company in town. They're up in, they're a Japanese company, but they also have a U.S. headquarters in Auburn Hills. And they both make manufacturing equipment for doors and body sides, as well as actually produce those themselves. So OEMs like GM can actually outsource them and have them provide doors to their plants for particular vehicles. So they're running a manufacturing process, and just coincidentally, when I was at GM as an engineer, I worked indoors, and they're very complicated pieces of equipment. They're very complicated designs, and they also all go together, so once it's done, it's done. Okay, and it tends to be highly automated. So if you have a problem, that shuts down the whole line, and it's not something I can quickly just pull off and necessarily fix. So you really need to understand what's going on at every part of that line. Where are my choke points in that process? How is my process running? And what they were able to do is, number one, they took the agile approach of saying, the other thing too is we don't want to make this a giant science project. We want to work, we're not in this to be an IT company. We're not in this to, basically build a giant system. So they set goals of things they could do in 6 weeks, and they bit those off, and they started to continually improve that. And to the point where, the plant manager can walk around with an app and see at any point in time anywhere in the world how his lines are running and what's going on that particular line. And another one which is interesting too, some companies don't allow us to let us know who they are, but this company makes large industrial pumps for things like gas lines and things like that. And this is another one where if the pump slows down or has an issue, you're just not pumping gas. You are losing money, right? And oftentimes these things are out in the middle of nowhere. It's not like they're conveniently located, in urban areas with lots of connectivity or whatever else, or lots of people for that matter. So being able to remotely monitor these and also go back and if something happens, be able to try and remotely work on that and fix that is hugely beneficial. And also to understand what happened and why I didn't necessarily get the gas output I thought I got at the end of the line, where I probably have more sensors and technology around that. So this was huge for them. They were actually able to increase their top line revenue generation significantly by just understanding and optimizing the entire system. Last thing I'm going to talk about is really addressing the skills gap in the future of work. And this is exciting for a couple of ways. One is manufacturers are at a very interesting convergence. So products themselves and manufacturing processes are getting far more complex. So there was an interesting article in Automotive News, I think it was last week, talking about the fact that one of the potential issues around the GM strike is the fact that productivity, at least estimates, some folks have estimated that GM's productivity, the amount of labor hours per vehicle has actually gone down. And it's not because they forgot how to make trucks and cars. One of the reasons, quite likely, is the fact that trucks are a heck of a lot more complicated now. And now when you buy something that's a $50,000, $60,000, $70,000 vehicle, it's got a lot of stuff in it. And all that stuff has to be put in place. So it actually takes a lot more labor to put all that different content in that vehicle. And oh, by the way, now I've got to train all these people on putting all this kind of different stuff in it. And it's not just things I buy, infotainment type things or what have you. There's a lot of additional safety equipment that are put in there as well. So it kind of comes from all locations. And we're hybridizing and we're doing things like that nature. When you hybridize, I now put a whole other engine and fuel system basically inside the vehicle as well. So products are getting extremely complicated. They're changing dramatically. We're doing things that that people have not done before. So we've got to educate the workers and also get the workers' input early on. Is this actually going to work? Are we going to be able? Is this the most efficient way to put it together? Then on top of that, we have the retiring baby boomers, and we have a major transition in the workforce. So people that are experienced, especially in manufacturing, they've been doing this for maybe 10, 15, 20 years, that probably know more about it than. Just on a side note, my definition of an experienced engineer is one that had somebody on the floor say, "Are you the idiot that did assign this?" You ever try to put it together? And you have to admit, yeah, I am. But they know more oftentimes about the product than the people that are designing it. Well, that doesn't happen anymore. So, and also, if you go to lower cost countries, in some places, they will do exactly what you want, no matter how stupid that happens to be. And they will give you exactly what you ask them for. So it had better be correct. And you better explain it to them in a way that's not language dependent and not dependent on you being there, right? And then, oh, by the way, we've got the new people that are coming in, the millennials or younger generations, are not all that interested in sitting down with a big book and trying to read through it, right? They're looking for different ways, they learn in a different way. They've learned, they've learned everything else in a different way. We need to accommodate more efficient and effective teaching technologies than just simply force people to do things the same old inefficient way. We did that because that's what we did back when we didn't have any of this technology. So it's an interesting challenge. We're kind of coming at it from both ways. And last example really is this group Beneteau. They make, if you're not familiar with them, they make big, giant, expensive yachts. So odds are you probably haven't bought one. I certainly haven't. So, but interestingly enough too, their business was also expanding. Their market was expanding, and they were approaching production capacity. And instead of trying to build a new plant, especially in this business, this is not one you want to start investing a ton of new capital in, because that market can dry up as well. So instead, what they did is they became much more efficient. They also digitized. They found new ways to train their workers, so their workers could actually, because these vehicles are also obviously have tons of uniqueness to them, even if they are built off of similar platforms, to communicate and educate them on exactly what they needed to do to speed up the entire delivery process. So with that, I think I've got a little bit of time to take some questions. Sure, go ahead.
You talked about from the beginning, from the service standpoint. So I work in a laser engineering company, and we have a lot of lasers within those plants.
Okay.
We have to monitor those lasers.
Okay.
I manage a service.
You mean your customers' lasers? Yes. Are you? So what he's saying is he works for a company that makes lasers and has them in customers' plants. Yes.
So the question is how do you manage the security communication with those lasers outside of the company? Because they're very big on.
Mm-hmm.
So how can you manage that data basically?
Well, there's two main challenges. So he's asking really, how do you manage that data, pulling information from your customers' locations? So there's a technology solution, but there's also a person, or a company-to-company solution. So many companies don't necessarily want you on their network, especially pulling data out of you on your network. Yeah. There are secure ways to do that, and sometimes it's just a matter of working through, the IT and OT organizations to say, I'm going VPN directly to this particular box, and that's the only thing I can see, and we're firewalled around it, or whatever else. So there are technology solutions for that. Other things, maybe you may need to, set up a different line of communication, right? So you can also do, wireless 4G or 5G, and see if you can communicate directly through something that's not on their network. Because so if you do that, then there's a matter then. Okay.
Lasers to incorporate, like you talked about, predictive maintenance.
Yes.
And repairs.
Right.
So the customers want to know exactly what's going on with their lasers, but we also need to know that information.
Right.
So automating those processes between multiple customers.
So we can talk about that, because he's really asking about how to actually pull that data out and manage it and work with it and provide everybody the information that they need. That's what these suites of technologies do. And we can talk actually after this, and I can talk more detail about it. Yeah. Yes, go ahead.
Yeah, do you see increased use of prognostics with the advent of autonomous vehicles?
You mean in the vehicle? Yes. So, but that's the whole conversation on autonomous vehicles, and it's nice to see people are finally starting to realize this, have gotten way out ahead of it, because for whatever reason, we seem to take probably one of the most difficult tasks around, or a task with almost a near infinite number of potential variables, and decide we were going to somehow automate that. It's already a huge part of it, because that's really what autonomous vehicles come down to, is the fact that I need to predict behavior of the things I'm looking at. I'm passing somebody on the street. What's the likelihood of them coming out based on the information I have on where they're moving, how they're moving, et cetera. So that's a huge part of that, but that's also a giant topic, yeah. And there's better folks than I am to discuss that. That's a good question. What I would also say, though, is that I'll take it back to the manufacturing side of things, and that is actually creating a whole new set of technologies that we've never used before, certainly never used in cars before. So you don't know the failure modes of things you've never used before. You can guess, and hopefully you guess correctly, but if you don't guess all of them, then you don't know. That's how you learn. right? That's, you know, in the 70s, that's why trim fell off the side of cars, because they stopped screwing it on, they started gluing it on, and they found out all the failure modes for adhesives. And once they figured out the failure modes for adhesives, the trim didn't fall off the cars anymore, at least not with the same level of regularity. So we're going to have to actually figure out some of these, and then while we're manufacturing that product, we're going to have to figure out what's driving the quality of that product, right? And be much more predictive about making parts, and potentially, instead of having to recall something when something goes bad, to be able to predict whether I'm actually making that product correctly or not. Are there other questions? Cool. Well, thank you very much.